Okay, so what about if the base is a fraction? Previously we said the base was always an integer in these style of questions, so let's just investigate what happens. Well, if I had something like 3/5 being cubed, let's just think what this actually means. It means 3/5 multiplied by itself 3 times. So it's 3/5 times 3/5 times 3/5, which is 3 times 3 times 3. Okay, that's 3 cubed. And on the denominator, it is 5 cubed. Okay, well, if I wanted to, I could work out the answer. It's 27 over 125. But I'm more interested in these two things that I've just underlined in blue. It looks like if you're doing a fraction to a power, you can just do the power to the numerator, and you can also apply the power to the denominator as well. So in general, if I had a over b to the power of n, that is a to the power of n over b to the power of n. And of course, this works in both ways. You could have something written like this, and you could write it like that, or vice versa, going back and forth between those. So let's actually have a go. Let's use the laws with these fractional bases. So I'm going to do these 3 quick examples up here. So I've got 2/5 cubed. Well, that's going to be 2 cubed over 5 cubed. 2 cubed is 8, and 5 cubed, 5 times 5 times 5, is 125. Now, I'm going to introduce these kind of powers like we might have had before. So I have got 100 over 81 to the power of a half. Well, I could say that that's the square root of 100 over 81. Or if I wanted to, I could actually say that it is 100 to the half over 81 to the half. 100 to the half is the square root of 100. 81 to the half is the square root of 81. The square root of 100 is 10, and the square root of 81 is 9. So it's 10 over 9, which I'm quite happy to leave the answer like that. Now, earlier on, we had the law that said if you do a to the power of minus b, you get 1 over a to the power of b. So we're going to try it for this question here, and then we're going to see if we can come up with a shortcut for what happens when you have a fraction to a negative power. So it's going to be 1 divided by 2 over 3. I'm doing 1 over this thing that we have here. Now, you might know what this is called, but I need to figure out what's going on. I'm going to show you 2 ways about this. Now, I can make this fraction, which has got a fraction inside it. I don't really like that, so I need to think about how I can deal with this. Well, you know with fractions, as long as you multiply the top and bottom by the same thing, you keep the fraction equivalent. So what could I multiply this denominator by that would stop it being a fraction? What could I multiply this by? I could times it by 3. If I times that by 3, I would have 2/3 times 3, which is just going to be 2. So that means I could say the bottom is 2. And I also need to multiply the top by 3 as well, because you have to do the same thing to the numerator and denominator for equivalent fractions. And if I do the 1 times 3, I get 3. So interestingly, when I do 1 over 2 over 3, it becomes 3 over 2. It kind of flips around. Now, I said I was going to show you this in 2 ways. This little piece that I've got here could be 1 divided by 2/3. So let me just show it to you in an alternative way. 1 divided by 2/3. Maybe you know with this, what you do is you do 1 and you change it from a divide to a multiply to divide fractions, and you flip this one over from 2 over 3 and you flip it to 3 over 2. And 1 multiplied by 3 over 2 is 3 over 2. So what we've done to go from the 2 over 3 to the 3 over 2 is we have done something which is called taking the reciprocal. Now, people usually think that the reciprocal just means, oh, you just flip it over. But actually, the flipping over comes from doing 1 divided by. So reciprocal does mean flip over. But really what it actually means is do 1 divided by the number. That's kind of like the posh way of what the reciprocal is. So that's an important keyword there. I mean, you can take the reciprocal of things like 4, that's 1 over 4, but we knew that that's what it did, because when you take the reciprocal of a, you get 1 over a. If you take the reciprocal of 5/6, you get 6 over 5. If you take the reciprocal of x over y, you get y over x. So in general, if you do a over b to the power of -1, the -1 is going to flip it to a b over a. I guess I probably should have said here that there's a power of 1. But really, when you have something to the power of 1, it just stays the same, which is why I'm not bothering putting like a power around any of this, because all the -1 is doing is taking a reciprocal. So we're going to, in the next video, combine all of the index laws together. So this is where we are going to be thinking the final sort of rule is if you do something to the power of -1 or a power of a negative, you are taking the reciprocal or flipping over. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.